Hi everyone, I'm here to take a bit small topic about Karl Pearson's coefficient correlation, which is used in the research aspects in the data analysis to find the relation between the variables. And through the presentations of the topic, we will discuss about the properties, features, and merits and demerits of the coefficient of correlations of Karl Pearson. First on Karl Pearson, it is a statistical concept used to measure how a strong relationship is between two variables. This is what meant by the Karl Pearson's of coefficient of correlation. It is a statistical concept used to measure how strong relationship is between two variables. And the correlation coefficient values is always lies between +1 and -1. And it says that if the correlation values is positive, then the relationship is similar and having identical between the two variables, and else if it is negative, the dissimilarity between the two variables is shown. So by using those those symbols or signals, we says about the relation between two variables which is identical or having dissimilarities. And Karl Pearson is the first person to provide a mathematical formula to measure the degree of relation between two variables. And by the 1890, he described a formula, mathematical formula, and it is denoted by the R, and it is known as a product moment correlation, so simple correlation coefficient. Then we can look to the Karl Pearson coefficient correlation formula. It is denoted by R. R is equal to sum of product of deviation from their respective means, that is sigma xy, divided by number of pairs n into standard deviation of x into standard deviation of y. Then that is R is equal to sigma x divided by n into x into mean standard deviation x into standard deviation y. And we can then discuss about the Karl Pearson coefficient of correlation features. First, it is says about the first knowledge of direction of coefficient of correlation. It is the first feature of Karl Pearson, which he says that this method of measuring coefficient of correlation gives us knowledge about the direction of relation between two variables. In other words, we can say that whether the relationship is positive or relationship is negative, which means if there is having a strong similarities or similarities or dissimilarities between these two variables, it is says about the direction of the coefficient of correlation. Second one, size of correlation. It is mean that indicate the size of relation between two variables. Besides, the correlation coefficient ranges between -1 and +1 about the sizes of relation, or how similarities, how much similarities are there, how they are dissimilar, or the amount of sample, the sizes of the similarities and dissimilarities is described through the Karl Pearson's coefficient correlation formula. Then indicate the magnitude and direction. This is says that the method is not only specific the magnitude of direct correlation between two variables, but also specific its direction. It means if two variables are directly related, then the correlation coefficient between the variables will be positive value. However, if two variables are inversely related, then the correlation coefficient between the variables will be negative value. So the direction also is described through the correlation coefficient features of Karl Pearson. It says as the first point, it's a knowledge of direction correlation is that it is all, and again it is described specified as the magnitude and direction is also described. Then the ideal measures. Ideal measures means that as this method is based on the most essential statistical measures such as standard deviation, mean, and it is an all these essential statistical measures are used in the Karl Pearson's formula. So it is used, and it is says as it is an appropriate or ideal measure or formula to measure the relation between relation. And we can say that it is says that the correlation values lies between the -1 and +1, where r is equal to +1. When it is the value is +1, then the positive correlation is occur. When r is -1, then the perfect negative correlation, there will be no similarities, only dissimilarity. When r is equal to 0, it means there is no or zero correlation. There will be no correlation or there will be zero correlation. It is denoted by those three signs. Next we can say about the properties. Properties of coefficient correlation is coefficient of correlation is independent of changes of change origin of scales of measurement. It is that it is not affected by any changes of origin or the scale of measurement. It doesn't affected if the scale or the origin is changed. The coefficient correlation is not changed. Next one, it is that it is always lies between the +1 and the -1 ranges, or the -1 and the +1 ranges. The property r is always serve as a useful check on the correctness of the calculation. If the values of r lies outside the range, then it would be means that there is some error in the calculation. The property says that the values of r always will be in between this -1 and +1. If the value is outside those two ranges, then the calculation is wrong. Then next one, zero correlation. If two variables is says x and y are independent of each other, in that case the coefficient correlation between them will be 0, because if those two having a separate or a definite properties or definite independent values or or any other independent features, then the real correlation values will be 0. Next one, measure of real linear relationship. It is says that the coefficient of correlation is a measure that help in determining the linear relation between the two variables. If both variables, we can say that x and y, increase or decrease together, then r will be positive. If one variable increases when other variable decreases or vice versa, then r will be negative, because one having the relationship, if the relationship is not going in a same pathway, the value will be -1. If they are going in a similar way, it will be +1. Next we can say about the merits and demerits of coefficient correlation. First one, merit, we can say popular method, mostly popular widely used method to study the correlation between the two variables. In the merit, we say that it is a popular method. It is widely used by the in the statistical activities, and to find the relation between, or to find the values of the coefficient correlation. Second one, degree and direction of correlation. The values on correlation coefficient not only summarize the degree of correlation, but also it says about the direction of the correlation. Then we can say about the demerits. Affected by the extreme value. If the two values of the two variables are extreme, then it will have a great impact on the values of correlation coefficient. Second one, it is assumption of relationship. The demerit is while determining correlation coefficient, it is always assumed that there is a relation between the variables without thinking whether assumption is correct or not. Demerit says that Karl Pearson coefficient having a negotiate about assumption of the relation is without having a thinking or having a checking of whether the assumption is correct or not. The last one is, it is says that about time consuming method. In comparison to the method of determining correlation coefficient, this method takes more times than the formula or the other method. The correlation coefficient takes more time. last one, it is about the possibility of wrong interpretation. While interpreting the values of coefficient of correlation using this method, the chance of misinterpreting the coefficients are more, because if there is uh, any mistakes to the assumptions, or if the assumptions get incorrect or the values get incorrect, there is a chances to misinterpret the coefficient are more. So through this slide we are discussing about the coefficient of correlation by the Karl Pearson, and where they are used, and the values, and these properties, features, and the merits and demerits. I hope all get understand the topic. Thank you.